In this video, you will learn how to find the greatest common factor of two or more numbers, and to do that, you will need to know how to list the factors of a number. You'll need to know how to distinguish between a prime and composite number, as well as how to write the prime factorization of a number. So that is what we're going to do in this lesson. So to begin, we need to understand what the word factor means. Now the word factor is an integer that multiplies together to get a product. So for example, if you're looking at the number 15 and you're told to find the factors of 15, the question is what numbers multiply together to get 15? Well, it could be 3 and 5 because 3 times 5 is 15, and it could actually also be 1 and 15 because 1 times 15 would equal 15. So the factors of 15 would be 3, 5, as well as 1 and 15. Now another definition is integers that divide a given integer with no remainder. All right, so if you can divide a number into the bigger number without a remainder, then that number is going to be a factor. So for example, we can say 4 is a factor of 20, and that's because 4 divides into 20 with no remainder. If I take 20 divided by 4, we get 5 with no remainder, therefore 4 would be a factor. Now let's try some more with this idea. Now if I were to ask you, is 5 a factor of 30? What would you say? Well, the answer is yes, because 30 divided by 5 is 6 with no remainder. I can divide 5 into 30 with no remainder, therefore 5 is a factor. Now if you were told, is 7 a factor of 30? The answer would be no, because 7 cannot be divided into 30 without a remainder. All right, so if there's no remainder, it is a factor. Here's another example. If I were to ask, is 6 a factor of 30? What would you tell me? Well, the answer here would be yes, because I can divide 30 by 6, which would equal 5, and there's no remainder. Now what about 7? Is 7 a factor of 30? Well, here the answer is no, because I cannot divide 30 by 7 without getting a remainder. If I do 30 divided by 7, I get 4 and 2 sevens. So the remainder is 2, therefore, because of the remainder, 7 is not a factor of 30. Now if I were to tell you to find all the factors of 30, so we know 6 is a factor, and in the last slide we had 5 was a factor. Now what if I said list all the factors of 30? Well, to do this, we need to determine what numbers would multiply together to get 30. So the first thing we have would be 1 times 30. That would equal 30. I could also do 2 times 15. I could also do 3 times 10. I could also do 5 times 6. All of those would equal 30. So if I look at each of these numbers that we multiplied by, the 1, 2, 3, 5, 6, 10, 15, and 30, all of those would be factors of 30, because those are numbers that are used to multiply to get to 30. So now that we know what factors mean, let's switch over and discuss the difference between different types of numbers. So we have two main categories here, and that is prime versus composite. Now prime numbers is numbers that are greater than 1 that has exactly 2 positive factors, 1 and itself. All right, so for example, if you look at the number 2, the number 2 is prime because the only way to get 2 is taking 1 times 2. So this would be prime. Looking at 3, we have 1 times 3, and there's no other way to get 3 except for that, so this would also be prime. Now if you look at 4, to get 4 we have 1 times 4, but we also have 2 times 2. So because we have the second set of factors right here, other than just 1 and itself, this would be the other one, which is called composite. And we could keep going for every number. We have 5. The ways to get 5 is 1 times 5. That's the only way to get 5. So this would again be prime. 6, we have 1 times 6 to get 6. but we also have 2 times 3. So because we have another set of factors other than 1 and itself, this would be composite. So we could keep going for every number, and every number would fall under one of these categories. So any number starting from 2. 1 does not count as either prime or composite. All right, so that prime and composite start at the number 2, and numbers bigger than 2 would fall under one of those categories. So here we see listed some prime numbers starting from 2. So we have 2, 3, 5, 7, 11, 13, 17, 19, etc. All these numbers are prime, except for 27. That should not be in there. All those numbers are prime because the only way to get to those numbers is by taking 1 times itself. All right, and then composite numbers would be, as we mentioned, things like 4 and 6, and then 8, 9, and 10, and 12, etc. All these numbers, not only do we have 1 and itself as a factor, but we also have another set of factors for each of these as well. So now from here, what we want to do is combine the concept of prime versus composite, as well as the idea of factors. And what we're going to do is we're going to take a number, we're going to take a composite number, and we're going to break it down as a product of prime factors. And this process is called prime factorization. So here's what we mean. If we have a number like 20, for example, 20 is composite, right? It's composite because not only do we have 1 times 20, we also have 2 times 10 and 4 times 5. So this would be a composite number. What I can do is I can break this number 20 down as a product of prime numbers. Product meaning multiply. And there's different ways we can do this, but as long as we break it down and so all the numbers are prime, then we're good. So 20 we could break down as maybe 4 times 5. All right, so we write 4 and a 5 here. So we've broken 20 down into smaller numbers. Now 5 is a prime number, right? So the 5 is good. We cannot break 5 down any further. But the 4 is composite. So what I can do is I can take the 4 and break it down further as a product of 2 times 2. So 2 times 2, 2 is prime. So now we've broken it down as far as we can. We cannot break 2 down any further. So what we have now is we have 20 broken down as 2 times 2, and then don't forget the 5 right here. So we have 2 times 2 times 5. That would equal 20. So we've broken down the number 20 into a product of prime numbers, where 2, 2, and 5 are all prime numbers, and we're multiplying them together to get to 20. All right, so this would be our prime factorization of the number 20 right here. Now remember how exponents work. If you have more than one number multiplied together, we could simplify and write those numbers with an exponent. So here, for example, we have 2 times 2. Because we have 2 2's, we can write this as 2 squared, or 2 to the second power. And we see that typed up right here, 2 to the second power. That is the same thing as saying 2 times 2. If we had 3 2's, it'd be 2 to the third power. If it was 4 2's, it'd be 2 to the fourth power, and etc. Okay, let's try another number. Let's take a look at the number 36. Now let's try to write 36 as a product of prime numbers. Well, 36 is composite, right? We can take maybe 2 times 18, or 4 times 9, or 3 times 12, or 6 times 6. Any of those ways we could break down 36. So it doesn't matter which numbers we choose, as long as they multiply to get 36. So we can maybe do 6 times 6 to get 36. And so now 36 is broken down into 2 smaller numbers multiplied together. However, 6 is still composite, meaning I can break this down further into a product of 2 other numbers. Now 6 I can break down as 2 times 3. So we have 2 times 3 for this 6, and then this 6 over here can break down as 2 times 3 as well. So what we have is 36 can be written as 2 times 3 times 2 times 3. Now we can rearrange these and put the 2's together. So we have two 2's together. So 2 times 2 would be the same thing as 2 squared. And then the 3's together, 3 times 3 would be 3 squared. So I can write 36 as a product of 2 squared times 3 squared. So that is my prime factorization of the number 36. Let's do one more example on this slide. Here we have the number 200, and we are to write the prime factorization of 200. Now 200, we can think of this in many different ways. It could be 2 times 100, or 4 times 50, or 5 times 40, and etc. So we just need to pick one way to break it down, and let's do actually 20 times 10, which would also give us 200. So if we choose 20 times 10, now we still have both numbers are composite. So we need to break down both of those numbers as a product of prime numbers. So the 20 can break down as a product of, let's make it 4 times 5. And the 10 can break down as 2 times 5. All right, so from here, we need to look at each of these numbers, and 4 is still composite. So the 4 can break down as a product of 2 times 2. So now 2 is prime. The 5 here is prime. This 2 is prime as well, and this 5 is prime. So what we've done is we've broken down 200 as a product of 2 times 2 times 5 times 2 times 5. And we can combine the numbers that are the same. So the 3 2's would give me 2 to the third power. And we see 2 5's, which we can write as 5 to the second power. So the prime factorization of the number 200 can be written as a product of 2 cubed times 5 squared. Now in a moment, we're going to use this idea of prime factorization to find what is called the greatest common factor. Now before we use that to find the greatest common factor, we need to understand conceptually what is the greatest common factor. What does that mean? So when we say greatest common factor, what we mean is we're trying to find the greatest factor that's in common between two numbers. Okay, so we're trying to find the greatest number that is a factor of each. So for example, if I said, what is the greatest common factor of 8 and 12? We're trying to find the greatest integer that is a factor of each 8 and 12. So thinking through 8, we have 1 times 8, or 2 times 4. Okay, for 12, we have 1 times 12, we have 2 times 6, and we have 3 times 4. So the question is, which one of these numbers is the biggest number that they both have in common? Well, notice the 4 for both the 8 and the 12. That is the biggest number that is a factor both of 8 and 12. So the answer is 4, and it's because of that reason, because it is the largest number that's a factor of both 8 and 12. Now we can use prime factorization to actually calculate this number. So instead of having to write out all the factors as we did here and think through and find which one's the biggest, we could actually calculate it. So here's how we do that with the same example. If we had the numbers 8 and 12, what we do is we take the prime factorization of both 8 and then of 12. So 8 is composite. That can break down as a product of 4 times 2. And 4 is still composite. So we can break down 4 as a product of 2 times 2. So what we have is 8 is a product of 2 times 2 times 2. So we have 3 2's multiplied to get 8. And then the 12 can break down. That would be 4 times 3. 4 is composite. That can break down as 2 times 2. And then 3 is already prime. So 12 is a product of 2 times 2 times 3. So once we do this, to find the greatest common factor, what we do is we see which factors are in common. So looking at the 8 and the 12, we notice that they both have a 2 in common, and then they have this other 2 in common. So I put those together, 2 times 2, that gives me 4, which is my greatest common factor of 8 and 12. Now this process we just used right here is going to be helpful, especially when you have maybe more than 2 numbers to find the greatest common factor of, or if the numbers you're working with are quite large. Alright, so let's try another example. Again, this is with relatively small numbers, but we can use this for any size of number. Here we see we're trying to find the greatest common factor of 12 and 24. So we can do 24 first if we want. We got to take the prime factorization of each of these numbers. So 24 can break down as maybe 4 times 6, both of which are composite. So 4 can break down further as 2 times 2. 6 can break down further as 2 times 3. So 24, I can write this as 2 times 2 times 2 times 3. And then 12 is 4 times 3. 4 can break down as 2 times 2. So 12 is a product of 2 times 2 times 3. And to find the greatest common factor, we see what factors are in common. So we have 2's, and then another set of 2's, and then a set of 3's in common. So we have 2 times 2 times 3, which would give us 12 as the greatest common factor. So the greatest common factor of 12 and 24 would be 12. All right, and in our last example, we're going to add another number along with this. So not only are we trying to find the greatest common factor of 12 and 24, we're trying to find the greatest common factor of 12, 24, and 30. And the process is exactly the same. So we break down 12, 24, and 30 as a product of prime numbers. And 24 and 12, we already broke that down in the last example. The only thing now is we need to put the number 30 along with this. So here's 30, and we can break this down as a product of prime numbers. So 30, we can think of this as 6 times 5, and then 6 would be 2 times 3. And the 5 is already prime, so 30 is a product of 2 times 3 times 5. So to find the greatest common factor of 3 or more numbers, what we do is we're trying to find what factors are in common for all 3 numbers. So looking at the 24, 12, and 30, the breakdown, the prime factorization of each of these, we see what numbers do all 3 have in common. Well, we see a 2 in common with all 3 numbers, and we also see a 3 in common. So if we take the 2 times the 3, that gives us our greatest common factor of 2 times 3, which would be 6. So the greatest common factor of all 3 of these numbers is 6. And that concludes our lesson for today. We will see you next time.